On this channel, we provide useful programming information with practical code examples. This time, we will discuss the best practices for Python's for loop. In Python, the for loop is one of the powerful tools to iterate over a collection of multiple elements. Here, we'll explore in detail the best practices for using the for loop. Enabling subtitles will make the code descriptions easier to understand. Python's basic for loop is relatively simple. For instance, you can output the elements of a list one by one as shown below. The above code outputs the elements, apple, banana, and cherry, in order. This is a relatively simple sample code, but a for loop can implement more complex scenarios. For example, you can use enumerate or zip to iterate over multiple lists simultaneously. Using enumerate, you can retrieve both the index and the element at the same time. Let's look at an example using zip. Using zip, you can iterate over multiple lists simultaneously. Using lists directly is convenient, but when working with large data, it's important to use clear and efficient syntax. For example, if you want to avoid duplicate list elements, you can use a set to prevent repeated output. In this example, a set is used to handle duplicate elements. When iterating over dictionaries, use the items method to access keys and values. This code iterates over the keys and values of a dictionary containing countries and their capitals, and prints them. Using list comprehensions can make code more concise and readable. This is effective when creating new lists with for loops. This code uses a list comprehension to compute the squares of integers from 0 to 9 and stores the results in a list. By adding conditions, you can perform filtering or other operations within the loop when specific actions are needed. This code uses a list comprehension to square only the even numbers from the numbers list and stores them in a new list. In Python, you can include an else clause in a loop. This only executes if the loop terminates naturally, without being interrupted by break. In this code, since the value 6 assigned to search_for is not present in the list. The loop runs to the end and then displays the message, number not found. Modifying an existing list inside a for loop can lead to unintended behavior or unpredictable results. Such operations should generally be avoided. This may produce unintended results and is not safe code. Instead, it is recommended to either create a new list or use an index-based loop to maintain stable code. By using appropriate data structures during the execution of the for loop, you can improve efficiency. Using generators for large data transformations or itertools for streamlining is effective. By using such generators, you can handle data in a flow-oriented manner instead of loading everything at once. By using itertools, you can efficiently process data such as infinite streams while maintaining control. For example, as shown above, you can generate a sequence of values using count and retrieve values only while a condition is met using takewhile. This allows for flexible and readable stream processing without the need to explicitly specify termination conditions. Python's for loop can handle a wide range of tasks, from simple iterations to complex transformations. However, improper usage can lead to unnecessary complexity and reduced efficiency. By following these best practices, you can write efficient code while also improving maintainability and readability. The source code for this video can be downloaded from the official website. If you like, please visit the URL in the description to aid your learning. See you in the next video. Please subscribe and give us a thumbs up.